Hi, Algebra 2 Honors students. This is Ms. Skokin. We're going to talk about Section 5.3, Solving Quadratic Equations by Factoring. Our objectives are write quadratic equations in intercept form and solve quadratic equations by factoring. Now, those two are related because intercept form means that we can see the x-intercepts. And the x-intercepts come from factoring the quadratic equation. So you can see here we've got factored form, that's also intercept form. And the FOIL method in our vocabulary is related to the factored form because when we FOIL, we multiply, remember first with first, then outside, inside, and last. So factoring takes them apart into factors and FOILing puts them back together in this form. All right, let's take a look at some examples of factoring. I think you probably remember most of these, but we're going to go through them just as a quick review. We always want to factor out the greatest common factor. So we're going to take a look at this 1, 2, 3, set this. So pause the video now and factor the greatest common factor out of these three terms. In order to do a good job of factoring, what I've done, and again, this is for your review, you won't have to do this every single time, but what I've done is I've shown each of those three numbers in factored form. And once they're in factored form, we can clearly see which numbers they have in common and can be factored out. And remember, it has to be common to all three. So once we can factor those out, everything that's left over is what we see on the inside of the parentheses, and what they have in common is on the outside of the parentheses. So once we've got it factored out, 5ab times 2a squared b plus 3a minus b squared. We also use grouping to help us factor. So we have factors here. 5 is a factor, a is a factor, b is a factor, and then the parentheses is a factor. We actually have 4 factors in our result. Now, we also factor by grouping, and when we see 4 terms or more terms, we're going to consider grouping to help us factor. What we want to check out is what do they have in common. And in this case, we see that the first 2 terms have x squared as a greatest common factor. The second 2 terms have negative 2 as a greatest common factor. So what we're going to do is factor out x squared from the first group, and we end up with x plus 5. And we factor out negative 2 from the second group, and we end up with x plus 5. Okay, so now we have another common factor, this x plus 5. So we can rewrite this as x squared minus 2 times the other factor of x plus 5. So now we've rewritten in factored form our original expression. Those were pretty easy. They're very Algebra 1 oriented. And you also learn how to factor trinomials in Algebra 1, but we'll again refresh memories on this. Remember that we're looking at factoring quadratics. This is the chapter on quadratics, and in this case, on the left, we have an a equals 1 type quadratic. So we have x squared plus bx plus c. Normally we have ax squared plus bx plus c, but the fact that the a is not there means that we have an a equal to 1, so it doesn't show up. So we want to factor x squared minus 3x minus 18. Pause the video now. See if you can remember how to do this. Because what you want to be able to do is find 2 numbers that when multiplied will end up equaling negative 18, and when added will equal negative 3. So through a process of elimination, we're going to start out with 1, and we know that 1 times negative 18 gives us negative 18. And when we add them together, we don't get negative 3, we get negative 17. So this is not going to be our set of factors that we're going to use. Then we move on to 2. 2 times negative 9 does give us negative 18, but when we add them together, we get negative 7. Again, not going to work for us. The third numbers that we chose, going in order, 3 and negative 6. Notice we did 1, 2, 3, those numbers that are on the left. Anyhow, 3 and negative 6, and when we add those together, we get negative 3. So this is the one that we're going to use. And the way that we format our factors is x plus, that's a positive 3, times x minus 6. And if you ever need to prove it to yourself that this will work, just FOIL the numbers, multiply them back out, and you'll see you get what we started out with. When you multiply them back out, you can see we get x squared minus 3x minus 18. So the correct factoring or factors for our original expression is x plus 3 times x minus 6. In the example on the right, it's a little bit different. Now we have an a term that is not equal to 1. So this one is a teeny bit more complicated, although we actually use the same procedure. There's also another procedure called the rainbow method. So you may have learned it using what is called the British method. You may have learned it using the rainbow method, or you may have learned it using trial and error. There are videos listed below. There are links to videos, online resources that I think will be helpful that'll show you both methods. So we need two numbers that will multiply to negative 24 and will add to 5. So we set up our t-table and we tried, again, going in 1, 2, 3 order, but knowing that we need, when we add the numbers together, we need to end up with a positive. So that means that the larger of our two numbers is going to be positive, and the smaller one will be negative because we have a negative term when we multiply them to each other. So we start out with negative 1 and 24. That gives us 23, which is not equal to 5. Then we try negative 2 and 12, which when we add them together we get 10. Again, not going to work. And then we try negative 3 with 8. When we add those together, we get 5. So we know that this is the right combination of numbers. Where we go from here is where the different methods are slightly different from one another. So what we're going to do is we're going to say that our a term we know was 6. We're going to start out with our a term, and we're going to write our factors as 6x minus 3, which is one of the numbers that we got. The other number that we got was 8, so this is going to show 6x plus, because it was a positive 8. Now what we need to do is we need to simplify those, if we can, in any way that we can, by dividing out a common factor. In the case of 6 and negative 3, we know that they share a common factor of 3. So if we were to divide out 3 from both of those, we would end up with 2x minus 1. In the other one, we know that 6x plus 8, they both have a common factor of 2. So when we divide that out, we would end up with 3x plus 4. To check ourselves, we multiply it back out. Once we FOIL those out, we see that our result, oh, you know what I just realized? These should not be x's, these should be y's. So I apologize for the x's everywhere that we should have y's. Anyhow, we can see that we multiply it back out and we end up with the same expression with which we started. All right, we have a few more different schemes that we need to go through, factoring the difference of two squares and factoring the sum and difference of two cubes. In both cases, we've got models that we're going to follow. So I'm going to ask you to pause the video, try these out, and check your answers when you turn the video back on. In example number 5, the important things that we need to do is to identify a and b so that we can follow the pattern. Once we identify that a is 2x, because when we square it, we end up with 4x squared, and we identify that b is 5, we can say that 4x squared minus 25 is equal to 2x minus 5 times 2x plus 5. Try the next example, but don't forget the rules that we learned on the previous page. What do we always do first? That's right, we always factor out the greatest common factor first. Now that you've remembered that, factor it out and then factor the difference of squares. Once we factor out the greatest common factor, it should be easy to factor that difference of squares. All right, let's take a look at factoring the sum and difference of two cubes. Once again, we have a pattern to follow. Identify a and identify b, and then show the difference of cubes in number 7 and the sum of cubes factored in number 8. Turn the video back on when you're ready to check your answer. How did you do following the pattern of the difference of cubes? Okay, time to try the next one. The next one is a sum of cubes, so follow the pattern for that one. All right, the sum of cubes, we're just going to follow the pattern. Again, first we identify A and B, and then we just plug in according to the formula that we have. The next one, example number 9, is a difference of cubes, but it's also a difference of squares. So see if that one, you can figure that one out. It's a little bit trickier. Just remember to take it in steps. Turn the video back on when you're ready to check your answer. Okay, that was definitely a tough one, and let's call it a challenge problem. Hopefully you were able to get the right answer by first finding what the squares were and treating it as a difference of squares, and then using the difference of cubes and the sum of cubes formulas. By the way, it would have worked either way you did it, but this way is a little bit neater. All right, try the next one where you're simplifying this fraction. In order to simplify, you have to factor first. So factor the numerator, factor the denominator, see if anything cancels out, and what's left over will be your simplified fraction. Turn the video back on when you're ready to check. Okay, how'd you do on number 10? Check your answer, go back and check your work if you need to, and then move on to the next page. We're going to be talking about the zero product rule, and this is something you're pretty familiar with, but now it has a name, and it's going to help us solve quadratic equations. All this says is that if the product of two real numbers is 0, then one of those two numbers has to be equal to 0. So if we're multiplying A and B, and A times B equals 0, then either A has to be 0 or B has to be 0. We're going to use this zero product rule, to solve the following examples. Pause the video and try these out. The first thing that you're going to need to do is rearrange and then solve using the zero product rule. So we factor, set it equal to 0, and then we know that one of those two factors has to be equal to 0. Our solution set ends up being -4 and 0. And let's go ahead and make the connection between what we've come up with as a solution set and what this is going to look like if we were to graph it as a related function. And if we were to graph this as a related function, what we would see is that we have a parabola that intersects the x-axis or has x-intercepts at -4 and at 0. Try the next example and see if you can use the zero product rule to solve this one. So this one goes back to where we were talking about in 5.2, where we had to factor when we had ax squared plus bx plus c, and the a term was not equal to 1. So what we did is we made our little t-table. We found two numbers that will multiply to 3 times 2, which is 6, and add to -5. We found those, and then we factored out any common factors. Once we got those factors, we set them equal to 0 and then solve for x. So now we have a solution set of -1/3 and 2. And those are the two places where this parabola crosses the x-axis or has x-intercepts. Next is example 13. This one you should be able to do without any problem. On example 13, we had a perfect square trinomial where x minus 3 squared is equal to 0. Remember what this looks like? This is the parabola that only touches the x-axis one time at x equals 3 and represents a single real solution. Example 14 on the next page says, what is the positive solution of the equation 2x squared minus 8x minus 42 is equal to 0? Just a warning, as you try this, remember you've got to get rid of the GCF first. So you can see the positive solution is x is equal to 7. The negative solution, x equals -3, doesn't answer the question, so we don't care about it. Read through the instructions on how to write a quadratic equation if we are given the roots carefully, and then try the example shown. Check your answer when you're finished giving it a good shot. Okay, that one was a little bit challenging. We have to set it up properly, showing the two factors, then show them as factors and equaling 0 when we multiply them. When we FOIL them all together and combine like terms, then the only thing we need to worry about is getting rid of the fractions. Once we've done that, we've got the quadratic equation. That's it for section 5.3. See you in section 5.4.